Welcome, physics sleuths and inquisitive souls. Welcome to Dynamic Gravity yet again. On this video, I would like to try and explain exactly how time dilation works through dynamic gravity. I guess first we should go over briefly General Relativity's definition of time dilation. It was proposed by Albert Einstein back a long time ago when he proposed, I believe, special relativity is when it comes from, if I'm not mistaken. And his equations for that are essentially this guy right here. Let me see here. Here is a calculator. And it's just basically a generic, very generic equation saying that the faster you go approaching the speed of light, the more intense time dilation will get until you are completely static by time and there's no more time. So there's some problems with this. I mean, yes, Einstein was right. Time dilation is real. It is contributed to or caused by gravity. He got this 100% right on the button. But his interpretation, or how general relativity interprets it, is the creation of the concept of space-time. The fact that space and time are intrinsically linked together somehow through mechanisms and pixie dust magic that we can't possibly explain to you because we have no idea how. And that's where it starts, becoming apparent that they really don't know what's going on here. They can't tell you on a subatomic level how time dilation is occurring. But dynamic gravity can. So let's get into that right now. All right. We got, first of all, generic space-time. I probably should explain this earlier. As you travel through one in the dip in one, you go in the dip in another with space-time. It's all BS. It's not real. It's just fantasy. It's pseudoscience, not science. So the way, I guess we should first explain what time is. Okay. Time is best described as change in your system, okay? So effectively, you can say that zero change in your system equates to zero time change difference, all right? So if nothing in your system changes, if no electrons or moving position around the position of the proton, there's nothing going on at any subatomic level or anything. Everything is, as far as you can tell, completely static and not moving in any way, shape, or form. You have now created time dilation that is 100%, where you're effectively, you have stopped time. And it's important to notice that according to Einstein, there's no reason why you shouldn't be able to go both ways with time. If you travel this way and you go forward in time, then theoretically you travel back the opposite direction. You should go reverse in time. But this is not what we observe in any experiment that has ever been done regarding time. As far as we can tell, and as far as according to dynamic gravity, time travel, actually changing your time into a different frame of time, like going back a year or forward a year, is impossible. It does not exist. There is absolutely no way to change time because, well, there's no way to go forward or backwards in time because all time is, remember, by definition, is change of your system. And the more the system changes, the more you can imply, the more time that has developed, that has transpired from when you made your last measurement. So you got to remember that's a very important concept. Although dynamic gravity predicts time dilation, it is impossible to actually time travel. It's just not possible. You can slow time down. But remember, there's no experiment that's ever been done to prove that time travel is possible, even just a microsecond going back into time. It's impossible. It does not exist. A good thing to understand, too, is that there's two different ways to do time dilation, okay? I should probably explain this. Here is just a calculator of time dilation. You can just see, we've got a change of time of 1 second, a relative velocity of 2 kilometers per second, which is, very fast. That's like a very fast jet. Actually, no, it'd be way faster than that. My bad. And even as fast as that going, I mean, look at how many magnitudes of order. We're like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like 11 magnitudes of order, before we get any change at all. And if we, go faster, okay, now it goes up a couple orders of magnitudes, at 20 kilometers per second, which is so fast, I don't think there's anything we can go 20 kilometers per second. We go even faster. Now we start getting to the point where, okay, it's still not even going to be apparent that your time dilated, but it is going to add up over time. And this is like what, 20,000 kilometers per second. So it just goes to show you how fast you have to go for this effect to realistically kick in. And here's a good graph that shows you this. As you can see, once you approach the speed of light, you're complete time dilation, complete stasis of time, no time being moved at all. But even you don't even really become noticeable until what, maybe like here it's like 0.9% the speed of light is where it really becomes obvious. Okay, we have a time paradox going on here. So you have to go very fast or be in a very strong gravitational field, like that of a super celestial, like a black hole or something. So let's explain what's going on with time. Why is it that time is being affected? All right. So let's say we got a celestial body here, right? And this celestial body is, it's got its gravitational field. It's emitting, because that's how gravity works according to dynamic gravity's fields. Although it's not really going to be polarized like this, it's going to be omnipolar, but it is what it is. So we've got our celestial object, right? And then let's say we've got a little rocket ship. It's a horrible rocket ship. I'm sorry, guys. I failed in making this rocket ship. But, right. So we've got this rocket ship, and this rocket ship is going to be flying through this field, all right, through the gravitational field. Now, as it does that, it's going to come across, the different layers of the field. And you could quantize, the gravitational field if you want it into different layers, like a magnetic field of such, if you really wanted to. This wouldn't be a horrible thing to do. And then every time you progress through one of these layers of the gravitational field, you're going to be affected by time travel. And you're like, well, but why is that? Okay, the reason why that is because keep in mind what time is. Time is movement of your system. So let's look at this at a subatomic level. Time is movement of atoms moving around with each other, or electrons that are moving around the proton, around the atom. All right, any movement is going to equate to time. So These two things, according to dynamic gravity, as we have learned or explained, are going to be controlled or affected by the displacement of the electromagnetic force. That's what gravity is, according to dynamic gravity. And so you have this projected electromagnetic force, coming from celestial bodies, and it is, let's go away from this, and let's just say we have a proton with a couple of electrons around it, all right? A proton and a couple electrons. Now, as these guys go through here, which all matter is made up of protons and electrons, this field, this gravitational field, this displaced electromagnetic field is going to exert force on both the proton and the electron. And that force is going to limit the movement of what can and cannot be done in your atom, as far as like electrons moving around and protons moving around. So effectively, the stronger the force of gravity that you have affecting on a molecule, the more force that's going to be pulling it in one direction or another. Like let's say this electron right here is really being affected by this gravitational field. It's going to be pulling on it from its parent proton, but also it's going to be pulling on it from this field. And what's going to end up happening is it's going to get kind of locked into place. I mean, it's still going to move around thanks to the beauty of quantum mechanics and everything like that. But the stronger the gravitational field, the less it moves. Hence, the less it ages, the less time that has traveled. So, and this occurs whether you're closer to the source of the gravitational field, if it's a strong enough gravitational field, or if you travel through enough of the field, it's going to be the exact same effect. Let's say it's the same effect as just being right here next to the celestial body versus traveling through it at this speed. They're going to exert the exact same amount of force on that electron orbiting the proton. And the more force that's exerted on it, the less freedom it has to do what it naturally wants to do, which is find equilibrium. Hence, you have destroyed the equilibrium that is going on in the atom, which means you have precarious things like time dilation that start to affect it, and it completely static of all time movements. Yeah, so I hope this explains a little bit better exactly what's going on a molecular level when you have time dilation. It's a very simple concept. Just know that as you get closer and closer to this gravitational field, more force is going to be exerted on this atom that's going to prevent it from finding equilibrium, and it's going to end up locking parts of this atom, like electrons or protons or whatever, more in place. Now, of course, to have complete time dilation with zero movement at all, zero aging, zero time that is traversed in the system from this point to this point whenever you measured it. Like I said, going according to the math, which is valid by Einstein, it's a very simple equation. It's not like he's got, his constant in there or Newton's constant in there or, any proportionality constant or, anything. It's just a very simple, the speed of light, the faster you go or the closer you get to a gravitational field, the more time he's got to go. And you got to get very, very extreme if you want to get right here to the point where it's 100%. All right. And there's just one more thing that I think you guys really need to know. And Einstein can't even tell you this, even though he did this. And it's right here. Why is it that he picked the speed of light as the speed for time dilation to measure it by. He can't tell you. I can, though, because I believe in dynamic gravity. And according to dynamic gravity, this field is being facilitated by the exact same particle that facilitates the electric and magnetic field, which is why gravity is so similar to magnetism in so many ways, like how it behaves and how it exerts force on things. It is being facilitated by the virtual photon. So this is the reason why you use the speed of light when you use this calculation for time dilation, because the virtual photon is traveling at the speed of light. And once you go faster than the virtual photons are going, the amount that you encounter traversing through a gravitational field goes exponentially so to like infinity so fast that it's insane. It's mind-boggling. So essentially, that's the reason why the speed of light is used. Is because that's the speed at which the virtual photons are traveling through time, or not through time, but through space. My bad. So now Einstein can't give you an explanation of why he used the speed of light. He'll just tell you that the speed of light is the fastest anything can go in the universe, he believes, and that's why he used it. Okay, but why is the speed of light the fastest anything can go in the universe, Einstein? Can you tell us that? And he can't. He has this beautiful equation which works. It's accurate, the best we can tell. But as far as like explaining why is this component here, nobody on the planet can give you a reasonable, logical explanation that makes sense, except for me and dynamic gravity. Because that is the speed at which gravity operates. Gravity propagates at the speed of light. The virtual photons, the particles that carry it, go at the speed of light. That is the reason why the speed of light is used. I hope this explains this whole thing, what's going on, guys. It's not the easiest concept to understand, I get it, but this should definitely give you a good heads up on how everything is being facilitated and what's going on a subatomic level, and why time dilation is a real thing in this world that we live in, but time travel is not. I hope that explains it. If not, leave some comments. I'll try and get to them. Have a great day. Thanks. Bye.
Like, subscribe, submit.